All right, we are going to head into the first part of adding and subtracting polynomials. I know you have touched on this before, quite a few years ago even, and you've kind of dealt with it over the years. It is very similar to a lot of the combining like terms that we do when we're just solving regular equations. But I do want to kind of briefly go over it and talk about one very key important part when it comes to subtracting polynomials on top of that. So I'm going to kind of bounce back and forth between these slides and the little notes app that we use to write things down so that you can see them solved nice and neat. In my writing, you can pause me at any time to write down what you need to write, and we will go from there. First thing I want to talk about is just adding polynomials, which is a lot of combining like terms and putting expressions in standard form after we've combined the like terms. Just a little friendly reminder that like terms mean they're the same variable with the same exponent. So in this case, if you're kind of looking at it broadly, the 3x to the fourth and the 6x to the fourth are like terms. The negative 5x squared and the 2x squared are like terms. Then the 1 and the negative 7 are like terms. Make sure that you are remembering to bring the sign with them when you are combining and not just taking the number. So you have to make sure you take negative 5x squared and 2x with you when you combine. So I am going to hop over to the Notes app and swing this way. Just so you can see, we'll do the top first ones really quick. We're going to do some adding. My tip to you, my hot tip from Miss Burke, that I've done this for a long time, just kind of rewrite everything all beneath it as if you were distributing this little positive sign here. That'll get you into the habit of doing what you're going to do when you're dealing with subtraction. So we're kind of just going to bring everybody down. So that we can look at this and go, all right, well, what like terms do we have? What can we combine? I have a x squared and an x squared. So 6 and positive 3 make 9x squared. And 7 and negative 1 make 6. That I have to make sure once everything is in its like terms, is it in standard form? Is it in decreasing variables all the way across? Yes, it is. So that is good. We can't go any farther. Same thing down here. These are binomials that we're adding together. There are 2 terms each. We're going to bring everybody down just to keep ourselves neat and tidy. And so we can truly see what we are working with and find our like terms. I have some x squareds. I have some constants. And then everything in this case is in like terms. They are in standard form. We are good. Down here, we're going to do that same thing. Bring everybody down first. Plus 9. We have a plus a negative g to the third, so it's really just minus g to the third plus 12g. Let me very briefly see if I can move this down a little. There we go. So into that, I want to combine any like terms I have. This 2g to the fourth does not have any like terms, so we'll leave him by himself. The minus 3g does have a like term in the 12g, so 12 minus 3 makes positive 9g. This 9 here is all by its lonesome, plus 9, and the minus g to the third is also by itself without any like terms. So once we've combined all of our like terms, we do have everything simplified where it needs to be. However, this is not in standard form because your exponents are not in decreasing order. So we are going to reorganize this. Make sure we bring the negative from over here with us so that it is in standard form. I'm going to let you sync on that for just a second, and then we are going to hop back over here to discuss the main difference and why the only thing that makes subtraction different. So what makes subtracting any different from adding? Yes, we do see obviously that subtraction is different from addition. They are opposite operations. They are inverse operations, so they are going to be different. But there is one step, and I did mention it a little bit earlier, that you do have to do. We do have to distribute the negative so that we're making sure we are working with it correctly, because a lot of times we tend to forget to distribute the negative, and then we're not working with the correct sign on all of our terms. So we want to, your steps will come up in just a second. So that gives you all of your steps. You're distributing the minus sign first, combining any like terms that you have, just like we did earlier, and then putting the expression in standard form so that it is organized, it's neat, and in the correct tidy form before we move on. The big key is that we are distributing the minus sign first. I did put these slides in your polynomial notes that you have, just so that you can access them at any time as well. So let's go ahead and do our two subtractions down here, and we will be good to go. We'll do one zoom at a time. So step one, like we mentioned, I'll do it in the pink. The big key here is to remember we need to distribute the negative, and there is that secret one here we could work with to make it a little bit easier. We have to distribute the negative. So what that really is doing is just switching all of these signs. We're going to keep the first bit the same. Plus 17. And I want to distribute the negative to both of these parts here. So negative for x to the third and negative 9. That gives me, when I'm combining like terms, I still have x to the thirds. Now I only have 2 of them. And I still have constants. I just have 8 constants. And then we'll do the same thing here. Whoop, a little bigger. There we go. Step one, first thing I have to do, always, every time when subtracting polynomials, if you want to always just kind of like distribute the positive when it comes to adding them, that's also kind of a good habit to get into. We're going to keep the first part just the way that it is, because we haven't touched it. And then let's distribute this negative through. Negative times negative 2w makes a positive 2w to the third. Negative to a positive 4w squared makes a negative 4w squared. And a negative to a negative w makes a positive w. The key is making sure we distribute that negative to all of the parts. We don't want to miss any. I can combine my like terms. There's no other fourth degrees. There is some other squareds, however, so 1 minus 4. There is a third. And there is just a w. However, like we can see, that's not quite in standard form. At first glance, it looks pretty close, so we might have left it. But the 3 and the 2 are technically switched. Make sure you bring their sign with them. Those were negative 3 squared, so we have to bring the negative 3 squared with us. I'm going to kind of zoom this out so you can see all of them at once. So you can pause, you can catch up, you can zoom in, you can do what you need to be successful with these. And I will see you guys later. There are some notes in the slides for you that I believe have some more examples if you want to try a little bit extra before we get back to work on Monday. I will see you soon.